Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you how you can solve the rank-nullity theorems related problems. Myself Dr. Harish Garg. You can simply follow my YouTube channel where you can find the various PY question series under the playlist of the IIT JAM solution. You can find the statistics as well as the mathematics PY questions in this lecture. Now, whenever you have a questions related to the rank-nullity theorem, your first target is always to construct this matrix. Fine. And what is the dimension of this matrix? It is always, remember, this is a very simple approach. I can tell you, it is always, remember, what is the dimension of the R3? 3. What is the dimension of this? Is a 3. You have to remember the first one is written from this side. Now once you have defined the dimension, write this element in terms of x1, x2, x3, x1, x2, x3. Second one is x1 minus x2, x1 minus x2, 0, 0, 0, 0. Now can you find the rank of this? You can see what if you convert into the row reduced echelon form, it will be 0, 0, 0. So rank will be 1. What is the nullity? Always remember, if you find the nullity, you have to take the number of the column vectors minus rank. Remember always the column vector, or you can take this value, dimension of this. So 3 minus 1 is 2. So dimension of the nullity is 2. Dimension of the nullity is 2 cancel. Both are same, but it is not same. It is my 2 which is a subset of 1. It is not possible. A is the right answer. Okay, it means T1 is the mapping. What is the dimension of this? M cross N. T2 is my matrix. Dimension is N cross M. And it is given that T1 and T2 is my bijective. Bijective means 1, 1 and on 2. So whenever you have the composition matrix, the T2 inside matrix is always 1, 1. Outside matrix is always on 2. Fine. Now, always remember my tips. When you can say T2 is my 1, 1, any of the matrix is said to be 1, 1. If you prove the rank of T2, what is the mapping is here. Fine. If you prove that the rank of is a 1, 1, sorry, firstly you can to prove the rank is 1, 1. Rank of 1, 1 means nullity of T2 will be 0. So if nullity will be 0, how you can find the rank? Subtract from the this number of the columns minus here. Fine. And T1 is my on 2. So that means your target is to prove T1 is on 2. That is the dimension should be the right hand side. So this is my condition. So rank of T2 is my M. So rank of T2 is N, cancelled. Both are satisfied. Rank of T1 is M, satisfied. This option is cancelled. Always remember, this is a very simple shortcut tricks. How you prove that any of the transformation is 1, 1? You prove either the nullity is 0 or the transformation is my first one. If you want to prove on 2, then you have to prove that transformation is my this one. Now again, what is the dimension of this? 3. Dimension of this 3. So your matrix will be 3 cross 3. Write the first element X, Y, Z. Y, Z. X, Z. Here. So this matrix is my here. So now you have to check the dimension, rank, and nullity. Find the determinant. Fine. So determinant will be 1 minus 0, minus 1, 0, minus 1, which is 2, non-zero. If the determinant is a non-zero, so the rank will be the maximum rank. Fine. So if the rank is here, what is the nullity? Number of the column vectors are my 3 minus rank. So nullity is 0, rank is 3 is the correct answer. Okay, N is my greater than equal to 2. So it has infinitely many value. I can assume N is my very simple one. So this value will comes my Z1, Z2. This number is my Z2, Z1. This number is my C2. What is the dimension of this is my 2. Dimension of this is my 2. So the matrix A has 2 cross 2. Then what are the bases of this? 1, 0, 0, 1. If I firstly take 1, 0, 1, 0, so it will be 0, 1, If I take as a 0, 1, it will be my 1, 0. Fine. Now look at that. T A is singular. What is the determinant of this? -1, non-zero. So it is not singular. Every eigenvalues of this, always remember student, whenever you have the matrix of 0, A, B, 0, fine. So then you can find the eigenvalues directly as plus minus product of AB. Fine. So according to this, what is the eigenvalues of this? It is plus minus square root of this is a plus minus 1, but he said 0. Cancel out. A is nilpotent. What is the meaning of nilpotent? Is eigenvalues are always 0 and 0, but it is not cancelled. The modulus of the eigenvalues is my plus 1. Fine. So this option is the correct option. Another tips related to this particular matrix, although this tips is not applicable for this example, whenever you have the diagonal entries 1, 1, then A square is always I. A cube is not I. Even powers are always I. A4 is I, A6 is I, and so on. But odd powers are not I. Always remember when you have the diagonal matrix as a 1 and this value as a 0. You can join my WhatsApp group also if you want to join with me and discuss various problems. Okay, now look at that. This is my dimension 3. It is 3. So it has 3 cross 3 value. There exists a scalar C. What is the value of the C? Not given. So you can choose any value. Say C is equal to 1. So then this matrix is my X, or I can say T minus I of X will be 0. Then your target is to find the rank of this. So clearly say this has a 0. When the system AX has a 0, that means it has infinitely many solutions or unique solution. Fine. Unique solution is only when the rank of A is the number of the column vectors of the A, and if you prove that the rank of A is not equal to the number of the column vector, then you have the infinitely many solutions. Now clearly says that he said it cannot be. So what is the meaning of that? If I say T minus I, so T minus I from here, what is the meaning of that? T minus I is a 0. So rank will not be equal to the number of the column vector because it has a 0. So it means the rank cannot be 3. T is a mapping from V to V. What is the V? V is not given, so I can simply choose V as a R square. So my S and T is a mapping from R2 to R2. It means both the matrix are from my 2 cross 2. Okay. What does it mean? It means T of V belongs to the kernel of the S. That's the meaning of this. Or you can say, what is the T of V? T of V means a range of T. This is the subset of nullity of S. Fine. So if this is there, you can find that dimension. That means the rank of the T is less than or equal to the nullity of the S. Rank of T is greater than equal to S. Rank of T is less than equal to S. Fine. Now you have to find the rank of the S. So I can apply how you can find the rank of the S. Number of the columns are my 2 minus nullity of S. Now nullity of S is my greater than of the rank of T. So I can substitute here. It will be less than or equal to 2 minus rank of T. What is that 2 minus rank of T? That means nullity of T. Now you can check about rank of the S less than of nullity of T. Rank of S is greater than. So C and D are my right answer. Okay. Chale, firstly we can solve it and then I will give you the simple tips. T is the mapping from R cube to R cube. Fine. Such that rank of T and the null space of the T are same. Then I can apply the Rank-nullity theorem. Rank of T, null space of T is the dimension of here. So if both are same, it means this value will be 3 So is it possible that the rank of any matrix will be 1.5? It is not possible. So first option is cancelled and 1 is 2, this option is cancelled. Look at the second one. T is a mapping from R square to R square such that rank of T and the null space of the T are same. So what does it mean? Again I can apply the rank-nullity theorem. So 2 times of the rank of T is the dimension of this. Is it possible? Yes, it is possible. So yes, second is my correct, first one is not. Now I will give you the tips. Whenever you have the mapping from Rn to Rn such that range of the T and the null space of the T are same, this is true only if n is even. Fine. If you remember my this shortcut tips, then you can solve this question again, because 3 is my odd, so again this cancel. 2 is my even, so yes, this is the correct option. Fine. Okay, look at this one. V is a finite dimension space. Again, dimension is not given to you, so I can say V is my R2. So capital T is my R2 to R2 with a linear transformation of this such that rank of T is my rank of T square, and you are talking about the null space. Fine. So what is the rank of this? This is my 2 minus null space of the T is a 2 minus null space of T square. What does it mean? N of T is N of T square. Fine. What is that? This R is range, so I can apply the dimension. So what is the dimension of this? It is also same as that of the dimension of this, so that means this is also same. Intersection will be fine. I assume X belongs to this. What does it mean? X belongs to my null space and X belongs to my range. So if X belongs to my this, it means T of X is my 0. If X belongs to the range, it means there exists a Y such that T of Y is my X. Fine. I can apply the transformation on the both sides. So it's a T square Y is Tx. T square will be Tx is 0. It means Y belongs to the null space of T square, and null square of this is my N of T. So if Y belongs to this, it means T of Y will be my 0. What is the T of Y? T of Y means X is my 0. So if X is 0, it means this option is my correct option. Okay, look at the last one. Nullity is my 0. What is the meaning of the nullity? Is rank will be my 2. Fine. So can you think about any of the matrix whose rank will not be 2? So clearly say, if I assume T is my 0, so what is my T square? Also 0, and you can see this condition satisfied. Rank both are 0, but you can see what is the rank of T? 0. What is the nullity of this? 2 minus 0, 2, which is not equal to 0. So this option is cancelled. Now this is my type 2. Fine. And this is one of the most important type. Always remember, whenever you have a polynomial of degree less than or equal to n, then the dimension of this Pn is n plus 1 always. For example, if I say P2, P2 means a polynomial of degree less than or equal to 2, then the dimension of P2 will be 3. Make sure, student, the equality must be there. If it is given that Pn is my polynomial of degree less than 7, so since equality is not there, you can convert into equality, that is a less than equal to 6. Fine. Now again your target is to write the matrix, because you are target to find the T. What is the dimension of the V? So V is the vector space of the polynomial degree less than or equal to 3. What is my dimension is 4. So it has a 4 dimension. What is the dimension of this? Is also 4. Fine. Now once you are talking about the polynomial, you can write as a 4 dimension, 1 x, x square, x cube. Fine. Now substitute this first value in here. If you take f of x is my 1, first number, what is the answer of this is 1, first derivative 0, 1. 1 is a constant, rest values are my 0. Second, if I take the x, what is the answer is x minus derivative is my 1, so this is 0. 0 is a constant, rest values are also 0. X square, if I take the x square, it is x square, derivative of the x square is 2x, it is my 2x square, it is minus x square, coefficient of x square is minus 1, rest values are 0. And the last part is if you take x cube, the derivative will be 3x square, so it will be minus 2x cube, so minus 2, rest values are 0. Fine. Now once you construct this matrix, what is the rank of this? So clearly say one rank is 0, so and rest are my diagonals, so the rank of T will be my 3. If somebody will ask you find the nullity, number of the column vectors minus rank is 1, so 3 is the right answer. So your target is to construct this matrix only. Again you can see it's a polynomial. Fine. What is the dimension of this? 4. What is the dimension of this? 3. So your target is to construct the 4 cross 3 matrix. So what are the elements? 1, x, x square, x cube. Take the first number 1. If you take the 1, it will be 0, it will be x. So the coefficient of x is 1, rest are my 0. If I take as a x, second derivative of the x is again 0, it will be my x square. Coefficient of the x square is 1, rest are my 0. It's a 4 cross 3. The last column is when you take x square, the derivative will be 2, is a x cube. So it's a constant. I can write a 2, x cube is 1, rest number are my 0. So this is my capital T. Which of the following is not the range of the T? Fine. Okay, what is this? Is my range always. Look at the column wise is my range always. X plus x square. Can you add, if I say this is my C1 column, can you add or subtract any of the columns so that you can get x plus x square? You can see if I add C1 plus C2, 0, x, x square, 0. You can get this one, but we need a not. So this option is cancelled. Can you make this term from the column? 2, that's a constant, x square, this term, and x cube. So if I add C2 plus C3, fine, you will get this term. So this option is also correct option. X plus x cube plus 2. 2 is my here, x is my this, x cube is my this. It means if I add C1 plus C3, then you can easily make this one. Can you make x plus 1? No, because x plus, that means these are there. You are unable to add. If you add them, it's a 2. If I add C1 plus C2, you are unable to make. So that's the right answer of this problem. What is the dimension of this? 3. Dimension of this is 5. So your target is to construct the 5 cross 3 values. 1, x, 1, 2, 3, 4, 5. Fine. So firstly, if you take p of x is my 1. So it is a 1. What is the p of x square? P of x square is also 1. So that means 1, 0, 0, 0, 0. If I take as a x, so that means p of x is my x. So right hand side is p of x square. P of x square is x square. The coefficient of the x square is 1. Rest values are my 0. Because it's a 3. So last column is x square. If you take as x square, p of x square will be x raised to power 4. So this is my 1. Rest values are my 0. Then the rank of the T. Clearly say the 2 rows are my 0. The rest of them are my rank. So this is my 3. Your target is to only construct this matrix with the help of the basis. Look at this another one. A degree is less than equal to 3p. So the dimension of this is 4. This is my 4. So my matrix will be 4 cross 4. I can write 1 x, x square, x cube. If I take as a 1, so if you compare them, it means a0 will be 1, a1 will be 0, a2 will be 0, a3 will be 0. If I substitute here, what will happen? Only x cube. So x cube coefficient 1, rest values are 0. Now if I take x means a1 will be 1, rest are my 0. So if a1 will be 1, it means x square is a 1. So x square is 1, rest are my 0. Then is a x square. If I take x square, a square will be 1, a2 1, x 1, 0. So we need a 4 columns. If you take x cube, a3 will be 1, 1, 0, 0, 0. So this is my capital M. Fine. Now you can see what I gave you the earlier tips. Whenever you have an identity matrix but in the reverse side, what I gave you, m square is always 1, m raised to power 4 is always 1, and so on. But odd power will not be I. M raised to power 5 is not I. Now look at the option. M square is equal to I. Is an even number? Is a I, correct. M is equal to minus I. You can see it is not a minus I. M is equal to I, not. M square, because it's an even number, it must be the I. So this option is also cancelled. B is my right answer. P3 is a degree at most 3. At most, that means equality appear. So what is the dimension of this? 4. So it has a 4 dimension. It has a 4 dimension. So I can write it as a 4 cross 4. 1 x square x cube. Firstly, I can take as a 1. So what is the second derivative of the 1 will be 0? Is a 1. So constant 1, rest values are my 0. If I take x, second derivative is a 0. X, so coefficient of x is a 1, rest values are my 0. If I take x square, second derivative will be my 2, x square will be here. Constant will be 2, x square will be 1. If I take x cube, second derivative will be my 6x and x cube. 6, 0, 0, 1. This is my capital T. Fine. Now your target is to define the 1, 1 and on 2. What is the rank of this? Rank of T is my 4 all are non-zeros, which is same as of the number of the rows. Fine. Now what is the nullity? Column minus rank. Fine. It is my 0. So whenever the nullity is 0, what is the meaning of that? T is 1, 1. Fine. So this option is cancelled. Not 1, 1. This option is cancelled. Now what is the rule for that T? If I say T is from V to W, when it's said to be the on 2, when you prove rank of T is the dimension of W. Fine. So what is that? What is the dimension of this? 4. And you can see rank is my 4, which is the dimension of this right hand side. So yes, this is on 2 as well. So both 1, 1 and on 2. Fine. Now I will give you the one more tips related to this problem. If T is my mapping from V to W such that dimension of V is dimension of W, fine, then you can say T is my 1, 1 if and only if T is my on 2. So look at it. What is the dimension of this? 4. This is also 4. So this property is satisfied. And I prove that rank of T is my 4. Nullity of this is my 0. So what does it mean? From here I got it's a 1, 1. So 1, 1 implies on 2. This condition happens only when both have the same dimension. Fine. So it means this option is again correct option. Or in other words, this means when you have the square matrix. Fine. Okay, look at this one. P2 is a polynomial of degree at most 2. So the dimension of this is my 3. M2R is a 2 cross 2. What is the dimension of this is? 4. So now, what is the size of this matrix? It's a 4, is a 3. So 4 cross 3. Fine. Now F is the polynomial. So what is the, it's a 4 cross 3. So I can take 1. Now remember, I can't take like of this. Why? Because this is not a polynomial. This is the matrix. Fine. So but the domain is my polynomial. So P3, what is the basis is 1x and x square. Fine. Now you can see 1x, if you firstly take a 1, so what is the, if I take f of x is 1, so this matrix will be 0, f of 2 will be 1, f of 0 is also 1, 0 0, f of 1 is also 1. So 1 minus 1 0, second number this, third number this, fourth number this. Always return this, this and this. Second, if I take f of x is my x, what is the value is 0, this is 2 0 0 1. So what is the answer is minus 2 0 0 1. Then if I take x square, it will be 0, then minus 4 0 0 1. So minus 4 0 0 1. So this is my matrix T. Fine. Once you construct the matrix, then you can easily see that. What is the rank of this matrix? Rank is my 2, which is not same as of the rank of this. What is the dimension of this? 4. So it means it is not same. What is the meaning of that? T is not onto. Fine. Also you can see what is the nullity? Number of the column vectors minus rank, which is 1, which is non-zero. It means is that T is 1 1? It is not 1 1. So first option, second option cancel out. What is the nullity of this transformation? Nullity is my 1, but he said nullity consists of the 2. So dimension is 2. This option cancel. You can see it has a range, means rank. Rank is my 2. Yes, I have obtained the 2 is the right. Moreover, you can see 0 0 0 1, that's my first column. Minus 2 0 0 1 is my second column. So yes, it's a dimension is my same, so it's a right answer. Okay, Pn is up again, n is my not given, so I can simply choose n is my 1. So what is that? Capital D is the mapping from P1 to P0, and capital T is the matrix from P1 to P2, such that when you take n1, it will be my a0 plus a1x. The right hand side will be only a1, because when n is 1, it's a 0. Capital T, when n is 1, it is my a0 a1x. It will be a1 plus x square. Fine. So what is my capital D? Dimension of the 0 means, what is the P0? Dimension is 1. It's a 1 means it's a 2. So it is my 1 cross 2. So what is the 1 cross? Basis of 1 is 1. If I substitute 1, what is the meaning of the 1 is? A0 is my 1. A1 will be 0. Then only it's a 1. So what is the answer is? 0. Because A1 is 0. Fine. Then what is my 1 cross 2? No. First row, 1 row, 2 columns. So it's a A0. What is the A? It's a A1. A constant and x will be, I can return this number is A0 into x. Fine. So A0 is my 0, coefficient 1. Sorry, I can return like here. A1, 0, 0, 1. What is the capital T? Capital T is the mapping matrix from 3, 2. So 1 x and x square. Fine. If you take as a 1, what is the meaning of the 1 is? A0 is 1. So A0 is 1 means x. This number is 0, 0. If I take x, x means A1 is my 1. So is x square is my 1. Rest number are 0. Fine. Now it's a 3 cross 2. Then you can find the dt minus td. What is a d into t? It's a 2 cross 2. D into t. No, it is not defined. 3 cross 2, 1 cross 2. It is not defined. D into t. It is not well defined. Fine. Okay. Anyhow, if you closely look about this function, what you obtained that? If you closely look about this function, capital D is nothing but my differentiation. a naught is 0, a1. Capital T is my integration. Fine. So if you multiply differentiation into integration, that will be my constant, that is a 1. Fine. T into D, integration into differentiation, again will be the constant. So your matrix will basically what will happen is a Pn, n is my 2 cross, so it is basically a 1 matrix. Fine. So the trace will be 2. Otherwise you can simply multiply them, dt into this. So I take n is 1, so it is my minus 1 cross, it is my plus 1 cross, this is my 1 plus 1 2, this is cancel out. C is the right answer of this problem. Okay, so look at this another one. What is the size is 2, this is 2, so it's my 2 cross 2. So I can take the first element as a 1 comma 0 of the R2. So if I take 1 0, it will be my 0 comma 1. Second element I can take as a 0 comma 1 because these are the bases. If I take 0 comma 1, it's a 0 comma 1. X is a 0, x comma y, sorry, first number is wrong. First number will be minus 1, x is my 1, minus 1 0 0 comma 1. Then this number will be here, so I can choose k is my 1. Fine. So what is my t square? If you multiply them, it's 1 0 0 1. Fine. So t square is equal to t, which is not equal to t. Fine. Moreover, you can say t square is my t square is my I. So first option is cancelled. Second is, when you again take k is equal to 1, it is my t cube. What is that t cube is? T, because t square is I, which is not equal to minus of t. So this option is also cancelled. Range of the t square. Can you find the t square from this? It is my 1 0 1 0, that is I. So range of the t square. What is the rank of this? Rank of the identity matrix is 2. So range, what is the rank of the t? Rank of t is my again 2. Both have the same, but he said proper. Proper means not equality. This is equal to is the right answer. You can again join my WhatsApp group if you are interested. Okay, M is my 4 cross 3 matrix. Fine. So what is the meaning of that? What is the matrix of this? It should be R3 to R4. Then only it's a 4 cross 3. Then it is a basics Li. Okay. What is that? If you have a T is any map, then it maps Li to Li. Fine. How you can prove that matrix is said to be the Li? If you prove that the determinant is a non-zero, or if you prove that the rank of the matrix is the number of the column vector, then you can say M is my Li. Fine. Now firstly you can construct that. M is not given to you. Okay. What is the rank of this matrix? If I say the rank will be 1, is it equal to the number of column vector? No, it means it is not Li, but he said Li. Rank is 2. If rank is 2, does it equal to the number of column? No, no. And if rank is 3, it means number of the column Li. So if and E1, E3 are also Li. So if I apply the M on the both side, this will also the Li. So yes, this is the right answer. Okay. Nullity of T, rank of T square. So rank of T square I can found as 7 minus nullity of T square. How I can find the nullity of T square? You have to find the minimum value. So firstly I can give the tips, and after that I will solve this problem by the two method. Remember, nullity of t raised to power n is always be n into nullity of t. Fine. So what is the nullity of t square? N will be my 2 into nullity of t, it is given as 2, so that means 4. If I substitute here, because it's a less than sign, so it will be greater than of this, greater than equal to 3. So we need a minimum value. 3 is the right answer. There is one more method. We all know rank of the AB is less than of minimum of rank of A, rank of B. So if I take rank of T square, that means T multiplied by T. So that is the minimum of rank of T, rank of T. So can you find the rank of T from here? Because you have a nullity, row minus 2, that's a 5. So this is 5, this is 5. So rank of T square is less than equal to 5. So that is a maximum value, but we need a minimum. What is the second? We all know the rank of the AB is greater than equal to rank of A plus rank of B minus number of the column vectors. So what is the rank of A is 5, rank of B is 5. If you construct the matrix here, what is the number of the columns? Dimension is 7, dimension is 7. So number of the columns is my 7. So you can see 5 plus 5 minus 3. And if I say this is rank of, if I choose A and B both are T. So what is this meaning of this? That means 3 is less than of rank of T square is less than of 5. And they are talking about the minimum. You can say the minimum is 3. If they are talking about the maximum, you can take the maximum as 5. But you can also remember this shortcut trick. Okay, Li. So what is that tips I have given you? If the determinant is my non-zero, or the rank of the M is the number of the column vectors. Fine. So if I see first case, what is my M? V1, V2, V3, V1, V2, V3, V1, V2, V3. Fine. It is my 3 cross 3. So you can find the rank, or otherwise determinant you can find. So 1, 0 minus 12, minus 1, 0 minus 15, minus 1, 8 minus 5. So minus 12 plus 15 minus 3, which is 0. So it is not Li. Look at the second value. Second pair is a V1, V2, V3, V1, V2, minus 1, 0, 1. So can I find the determinant? 1 minus 0 plus 1, 0 plus 1. Is it true? Yes. So 1, sorry, is 1 minus 0, fine. Minus minus plus 1, and it's a minus of 1, and here. So 1 minus 1, 0. So it is also not satisfied. You can see these are my 4 vectors. So the size of this matrix will be 3 cross 4. It has the 3 row. Can you think that the rank will be 4? If you have the 3 row, can the rank be the 4? No. So that means this option is also cancelled. Only left option is my third is the right answer. But you can also check that V1, V2, V3, V1, V2, V3, 3, 0, 1. So what is the determinant? 1 minus 0, 0 minus 6. So clearly says 7, which is non-zero. Yes, this is my L. Okay, look at the rank of the T, which is dimension of the T. What is that? The size of this is 9. 9 minus nullity of T. Fine. So can you define the matrix T? This is my 9 dimension. It is also 9. Fine. Now what is the P? P is the element of the M3 cross 3. So it means this T into P, basically this matrix is my Q, because this is just like here. Fine. So that's a very simple. What is the rank of the Q? Rank of Q is my 2, which is not same of the number of the column vectors. Fine. It means Q is my not Li. Fine. It is also not 1, 1 and on 2. So I can find the nullity from here. Fine. So it means, what does it mean? If it is not a 1, 1, I can say nullity will be like of, what is the dimension of this is 9 minus rank of Q into, what is the P, what is the row, what is the column of the P is 3. So I can substitute here. Rank of this is 2 into 3. So 6, 3. I can substitute here. 9 minus 3, 6 is the right answer. Fine. Because the rank of the Q, because TP, this P is a part of this. So it just like a basis. Fine. So you can take any element of the P. So it will be the Q. So Q is my not Li. So you can write like here. Okay, which of the following is LD? Okay, always remember when you can say the matrix is Li, when the determinant is non-zero. So opposite is when you can say the matrix is LD, when you can say the determinant is 0. So I can write the firstly matrix. So first element is x minus 1 0, 0 minus 1 x x, 1 minus 1 1 0. So it is my 4 cross 3. Fine. If I call it as a M, now it is a LD. So also we can say Li means rank of the M is the number of column vectors, and if it is LD, it means rank of the M is not equal to the number of the column vectors. Now it is given that this is a LD. So what is the meaning of that? Rank of the M is not equal to the number of the column vectors. So when it will not be the 3, when it will not be the 3, when you have, it means rank is not 3, it means the rank is either 1 or 2. Fine. So if I take any of the 2 cross 2, if I found the determinant here, fine. So what you can say, this will be, no, it means from here x will be 0. Fine. But if x is 0, then it is my Li, because 0 0 and here. So I can find the 3 cross 3 matrix and whose determinant will be non-zero. So for the LD I can write here, because M is my LD. So what is the meaning of that? Rank of the M should be less than of the 3 column vectors. Now it means that you can take any of the 3 cross 3 matrix, minus 1 x1, the determinant should be 0. Fine. Now I can expand it. So it is minus 1 plus x, 0 plus 1 is minus x, minus 1 is 0. So if I open this bracket, minus x plus x square minus x minus 1 0. So that means x square minus 2x minus 1 is 0. Is it okay? Now how you can find this factor? Can you get the answer of this? How you can solve this? Let me check is my calculation is correct. Minus 1 plus x, fine, plus 1 will be minus x, sorry, minus plus 1. No, where is the error is? It's a 0, you can't expand them. It will be 1. It is my minus x square. It is wrong. Fine. I corresponding to this, it is my minus x square minus plus and minus 1. This is 0. Now I can open this, minus x plus x square minus x square minus 1 0. So what is the meaning of that? X will be minus 1. So what is the value of the x they are talking about? That's the minus 1. Okay, T is the linear transformation K. Okay, I can choose n is my 2. So capital T is a mapping from R2 to R2. K is less than or equal to n. So I can choose also K is my 2. Fine. Then your E will be V1, V2. Capital F will be my V1, V2. Fine. E is my Li. E is my Li, then F is my Li. Okay, no, fine. Okay, firstly I assume F is my Li. Fine. So how you can prove that? Okay, I can simply take a counter example. It's a linear transformation. I can define what is the meaning of the Li. If I take any of the matrix whose determinant is a 0, like this, fine. So it means whatever the matrix I have obtained, this is my not Li, because the determinant is a 0. So what I can say, if I construct T of V1 is my 1, 0, that means E1, fine, and T of V2 will be my 0, fine. So clearly say E1, so I can say this is my E1, this is my E2. Clearly say E1 and E2 are Li, but this matrix is my not Li. F is my Li, F is my Li. So firstly I can choose any matrix whose this value is a non-zero. Okay, this is the reverse. I can see here E is my Li and this is my LD. What is the meaning of the LD? Determinant is a 0. So I can choose one matrix to be here, fine. So clearly say that determinant is a non-zero. That means if I choose T of E1 is here, this is my E2, fine. So clearly say this is my Li, E1 and E2 are Li, and this is also Li, but he said dependent. Again this is dependent, so that's only option is B is the right answer. Okay, W is the vector space of this. S is my here, which of the following is necessary true? Basis kernel of this. S, T of E2, E4, E6, that is spam W, fine, and this one. Okay, so what is the meaning? This is a spam of the W, fine. So what I can say, the dimension of W must be less than of the dimension of the T. What is the dimension of the T is 6, fine. So dimension of, no, just wait, just think about something else. Dimension of W, because S spam the W. So what is the, how many elements are there? 3 elements. So the dimension of this must be less than or equal to 3. So what is the dimension of W? If you find the dimension of W, because we need a capital T, I need the kernel rank of this. Okay, S is a basis of W. Can it form a basis? It is not always true, because if I assume T of this is my 0, then it has less number of elements. So it means it is not necessary it's a basis. T of 6 is not equal to W. This is not always true. If you prove that this is my onto, then it will be here, fine. So how I can do that? So from here I can say the rank of T is less than of this one, because dimension of W is related to the rank of T. So what is the nullity of T? Nullity of T will be 6 minus rank of T. It's a less than 6 minus 3 is a greater than or equal to 3. Kernel means nullity is more than one element, definitely is the right answer. And clearly say this is also a wrong option, because it is not a basis. It is true, but it is not always true. So that's why D is the right answer. Okay, capital T is the mapping from here. A, B, C are the real numbers, not all 0. I can assume A is my 1, B is my 0, C is my 0, because not all are 0, rest many of them are 0. So if I say capital T is my this, what is that? It's a 0, 1, 0, minus 1, 0, 0, 0, 0, 0, fine. It's a R3 to 3, it's a 3 cross 3. Then 1, 1 on 2 and so on. So can you find the rank of this? Rank of T is my 2. What is the nullity of is number of the column vectors? Minus 2, 1, which is not 0. It means it is not onto, fine. So B option is cancelled. When it will be the 1, 1, if you have the mapping of this, when it will be the 1, 1, when the rank is same of the dimension of R3, that is 3, but you can see the rank is not same of this dimension. So it means this is not 1. Moreover, if you remember my earlier tips, what I told you, if you have a mapping whose dimensions are same, then this is 1 1 if and only if it is onto, and I prove that it is not onto, it implies that it is not 1 1. So first option is cancelled. What is the rank is 2, but he said rank 1. This option is also cancelled. Only left option is the right answer. Again you can see capital T is the mapping from R3 to R3 such that the basis of this, that means 0 0 1 0 1 0 1 0 0. Then it has a distinct eigenvalues, has the eigenvector non-zero null space, that is a nullity. So firstly I can find the rank of this. So clearly say rank is 3. What is a null space? Number of the column vectors minus 3 is a 0. That means it has a non-zero null space cross. 0 means T is my 1 1. Fine. Also it has the same dimension, so you can say this is also implies T is onto. Fine. Now T has the distinct eigenvalues. How you can find the eigenvalues of this matrix? Again a very simple, you can see this is my diagonal values. So what I told you, if you have 0 A B 0, only the 2 cross 2, what are my eigenvalues? Plus minus root of AB. So I can think about 2 by 2 here. What is the eigenvalue of this? Plus minus 1, and this has a 1 is the left behind. Fine. Otherwise I can write this matrix again. You can see from, I can partition them. Fine. So you can see this is a Jordan block, but Jordan block if is not in your syllabus, you can simply look about that. This is my here. Fine. What is the eigenvalue of this first portion? The eigenvalue of this first portion is plus minus 1, and this is a single element is a 1. So eigenvalues are minus 1, 1 and 1. Fine. So it has a distinct eigenvalue. You can see, is the distinct eigenvalue? No, because it has a 2 same eigenvalues as well. It mapped the subspace spanned by E1 and E2 itself. What is the meaning of the E1 and E2? That means first and second. Fine. How you can prove that? Span of E1 and E2, that means x, y, 0. That's the meaning of this. So now if I multiply this by x, y and 0, what will happen? X, y, 0. So it will be 0, 0, 0, 0, y, 0, 0, x, 0. So that means 0, y, x. Fine. So does it which space? X1, x plane, y plane. But here the first component is my 0. So what is the meaning of that? When x is 0, it means it is my yz plane. But he said x, y plane, but we get a yz plane. So the only option left behind is my C is the right. Okay. Capital T is the mapping such that this condition is given to you. Fine. Capital T is my R4 to R4. Okay. Now it has the dimension 4, but it is not the degree 4. It means this is my annihilating polynomial. It is not a characteristics polynomial. Fine. If it is a characteristics polynomial, only when it has a degree 4. Then consider the matrix T such that T4 plus 3T cube minus 4I. Fine. So now it's a degree 4. It can be the characteristics equation of this. So clearly say I can substitute capital T, I can take common, plus 3T square minus 4I. So what is that? It's a 4I. Okay. So 4 capital T minus 4I. That means capital T minus I of 4. Then T is 1 1. Then S is 1 1. S is not. So clearly say if I take T is equal to y, I. Okay. Is it satisfied this equation? Is it satisfied this equation? I plus 3I is equal to 4. Satisfied. Fine. So it means if I take t is equal to I, what will be your s? S will be 0. So once s is 0, what is the rank of the s? 0. What is the nullity of the s? Dimension is my 4. 4 minus 0, 4, which is non-zero. It means s is not 1, 1, but he said 1, 1. Also, the dimensions are same. So if it is not 1, 1, it means it is not onto. Now, what is the meaning of that? If s is 0, does it invertible? What is the determinant of s? 0. Is it invertible? Not invertible. So the right answer is D is the correct answer. Okay, look at this another one. V is the vector space of all those polynomial with a degree at most 5. It means this has the degree 6. T is the mapping of this. You have to find the T of x4 and x cube. Very simple. If I choose k is equal to 1 is already given. If I choose k is equal to 2, what is the meaning of this? This number will be x minus 2 plus 1. That means x minus 1. Only first two terms. That is x squared minus x is my 1. Fine. Now it is a linear map. So what is the meaning of that? T of x squared minus t of x is my 1. T of 1 is my 1. Fine. So if I choose at x is equal to 1, okay, no issue. If I choose k is equal to 1 also, what is the answer of this? It's only tx. T of x is my 1. So what is the answer of that? T of x square? 1 plus 1, 2. Now if I choose k is equal to 3, this number is x minus 2. That means x minus 1, x minus 2 is 1. So if I open this bracket, it is a x cube, 3x square plus 2x is my 1. Now if I open this bracket, it's a t of x cube. T of x square is my 2, so it's my 6. T of x is my 1, it is my this. So t of x cube will be, it is my minus 4 plus 5. So t of x cube is 5. B is the correct answer. Now look at the x raised to power 4. So I can choose k is equal to 4. It will be x minus 1, x minus 2, x minus 3, which is 1. Fine. Now I can open this bracket. What will happen? It is t of x square minus x, and this is x square minus 5x plus 6, which is 1. Again I can open this. It is x4 minus 5x cube plus 6x square minus x cube, 5x square minus 6x is equal to 1. Now I substitute the values. This, what is x cube? I obtained as a 5, so it's a minus 25. T of x square I computed as a 2 earlier, so it is my plus 12. X cube I computed as a 5, x square I computed as a 2, t of x I computed as a 1. So can you find the value of the t of x4, which is minus 13, it is minus 11 plus 10 is a minus 1. So it means t of x4 will be is a 14 plus 1 is 15 is the right answer of this problem. So this is the way you can easily solve this problem. Look at the 2023. S and T are the non-empty subset of the R square. W is the proper subset of the R square, non-zero. Then span of this of this. So firstly say R2. Span of the S. What is the S? I can choose S as a, what is the basis of this? 1, 0. Fine. Now span of this is my R2. Fine. Is it satisfied? Then what is the W? Is a non-proper subspace, non-zero proper subspace. So what I can do about that? I can assume any of the subspace of the R2. What is my subspace of the R2 is subspace. So subspace is always passing through the origin. So I can choose as my say x comma x. Fine. Like 1, 1, 2, 2 and so on. Then what will be my intersection? Is there any common part? There is no common part. So what is the span of the phi? Span of the phi is also phi, but w is my non-zero. It means this option is wrong option. Now look at this another one. In this case there is no need of the w, so that's very simple. Is it okay or not? Okay. S and T are the two subset, so I can choose a subset of 1, 0 is my simple S, span of the S. T is my only 0, 1. Fine. So what is the left hand side is R2 complete. What is that 1, 0 is this line. Fine. This is of my capital S. No, sorry. This is second part, so we have to remove this first portion. Okay. Now in the second case, it is this condition is not given to you. I have chosen this S and T. Then what is my S union T? This is my R2. Fine. So what is the S is? This is my S. What is my capital T is? This is my capital T. So what is the span of this? Span of S union T is basically my R2. Fine. What is the span of S? Is my this union span of the T. What is the meaning of the union? That means 1, 0 union 0, 1. Fine. But if you clearly say, if I take the 2, 2 from the R2 left hand side, does it belongs to this? No. So it means they are not equal. Fine. So both are my false state. Moreover, you also knows that the intersection of the subspaces is also the subspace, but the union of the subspace may not be a subspace. Fine. You all already studied the group theory that if H is my subspace, subgroup, K is my subgroup, union of them is a subgroup only when one of them is contained in the others. The same concept is applicable in the subspace. Union of the two subspace need not be a subspace. So both the options are correct. Cancel. D is my correct answer. We will see the next lecture on this infinite series. Till then, you can simply like, share and comment on my video. Best of luck, students. Happy learning.